Okay, I think I'll start now. So basically today is just you're getting a basic review of what different web protocols are, and also you're gonna get familiar with how to use the intruder on Burp. So getting started, we start off with the OSI model, which is basically it explains networking in 7 layers because otherwise the complexity of this whole thing is just too much. You start off with the physical layer, which is responsible for exactly how the digital signals are produced and transmitted. And then you go on to other layers, which, yep, I've started recording, don't worry. And then you progress to other layers, which basically just build on top of that, and you get an entire website where you can. Okay, so anyway, on to the different layers, and we start from the ground up. Forgetting about all the different servers and forgetting about TCP and forgetting about all the protocols, just imagine a bunch of computers connected to a common medium. And this medium is called the carrier. So basically, say that computer A here wants to send a message to E. Basically, it just sends that message over the carrier, and every other computer connected to the carrier can hear the signal, basically. But since we don't know which computer needs to address that signal, it usually prefixes this by the MAC address of computer E. The MAC address is basically something that uniquely identifies every physical device. It's slightly different from IP because IP can change based on your network configurations and what you're connected to. So basically, on this carrier, you can imagine this as an Ethernet cable, or you can imagine this as your local Wi-Fi. The shared carrier in the case of Wi-Fi would be the air, and in case of Ethernet, it'll be the cable itself. So basically, what happens here if two computers want to send a message at the same time? Suppose A and C want to send a message using the same carrier at the same time, then the signals would get all mixed up, and that's called a collision. And we don't want that to happen. So basically, but the good thing about this is that computers can listen for whether or not there's a signal on the carrier, and they can basically prevent collisions by just waiting before the other computer is done, and then waiting a while, and then transmitting the signal when the line's empty. It obviously won't work if all the computers will wait the same amount of time, because what happens is that two colliding computers will just wake up a second later and then they'll collide again. So to prevent that, we usually add like a arbitrary small time period. So suppose computer A waits like 3 seconds, computer C will wait 3.2 or something like that. And basically, as the number of signals that computers try to pass around increases and congestion increases, what happens is that there's an increase in this wait time exponentially. So suppose first you wait 3 seconds, then you might wait a 9, and then 27, and so on. It's obviously not seconds, it's in the order of a couple milliseconds maybe, but that's about the concept that goes on there. Okay, so anyway, this is for a single carrier, and all the devices are connected to this one single carrier. But obviously, this might not always be necessary. Say you have a very large number of computers. It doesn't make sense for all of them to share the same carrier and just wait when there's multiple requests that need to get through. So basically, this here, all these computers sharing the same wire, these form a collision domain. To reduce collisions and basically for different computers to be able to send messages at the same time, we have something called a switch that just operates between two different collision domains. So in this example, I could create one domain. We could make a switch sit in between ABC and DE. So in that case, what happens is if A wanted to send a message to C and D wanted to send a message to E, without the switch, they would have to wait an additional amount of time, and they'd have to wait for the carrier to be empty, and then they'd be able to send the signal. But with the switch, they're able to do it simultaneously, and the switch is only activated when some computer on one side has to transmit something on the other side. So that significantly improves how many messages overall we can send. And switches basically do this by just keeping a list of computers on both sides. And if you think about it, this is pretty much what the internet is. It's a bunch of collision domains with a bunch of switches and routers in between. And we just, every time you want to send a message to some other computer on the other side, you want to send a request to something that's in a different collision domain, these switches are activated. And you finally hop and you get to the computer you're supposed to go to. Okay, so this is very low level stuff. This is just the data link layer. And next up we have, okay, so far we've just been talking about messages as a whole, except it might not be efficient for one person to send like a, say like a file that's a few megabytes. That's fairly large. And while the message is being sent, all the other computers that also want to use the resources can't because the message is still getting sent. So basically, to solve that, people came up with this idea of dividing messages into a bunch of small packets. Um, uh, so basically, they divide messages into a bunch of small packets, and when you're sending it across to some other computer, you only need the destination IP address of that computer, and it'll get there. There's obviously, again, IP is a very low-level protocol. All it has is, I don't know if you can see this, but it has version length, source IP address, destination IP address. That's all it has, and data. So once the packet gets to its destination, your computer is going to have to know how to order it to make it, make it a meaningful message. So on top of that, you have other protocols in the transport layer running on top of IP that help you order packets. Actually, UDP does not help you order packets. Anyway, we'll examine the difference between these two. UDP is something that basically just, it sends a bunch of packets and it has like a header in front of. So IP has its own header, as we saw. It has a destination IP address, and then that's followed by the data payload. UDP adds its own header to the thing, which basically has a bunch of things like port number, checksum, and all those. So it basically tells you so port numbers are, I have a slide on it later. Basically, if you're sending a packet over the internet to someone, the IP addresses will help you get to the right device, but you also have to get through to the right application once you get to the right device. Like Skype might be requesting a bunch of packets. YouTube might be requesting a bunch of packets, or a bunch of applications might be running simultaneously, and you kind of have to know which packets to send to which application. And that's what port numbers are for. So anyway, UDP adds its own headers to the thing, and it's different from TCP because it only sends the packets with its headers, and that's all. It doesn't check if the packet got there. There's no mechanism to recover lost bits. There's no mechanism of like figuring out if the packet got there or not. It just sends it and that's it. TCP is different because for every bit that it sends, it also requires that an acknowledgement bit is sent back to acknowledge that, yes, okay, this packet was received. So yeah, it's used in applications where it's critical to get all the bits. So for emails, for web browsing or file transfers. But UDP is used where it's where the important thing is not to get all the bits. It's okay to lose a few or discard corrupt bits. But it's much faster because with TCP, you're essentially transporting double the amount of data because you have your SYN bits and you have your ACK bits. You have your packets itself, and there also has to be an acknowledgement. So you're effectively using twice the amount of bandwidth, but for the same amount of data. So in applications where you just have like really large volumes of data and you just have to, it doesn't matter if a few bits are lost, you would use UDP. Okay, so now we figured out how packets get from your IP address to a different one. But it's not always rational to know that you can't remember IP addresses of every single um, server out there. You can't always remember a bunch of numbers. So you have something called the domain name system, which basically maps a bunch of domain names like google.com or youtube.com to a bunch of IP addresses. So basically, when you do a DNS lookup, or you basically type a domain name into your browser, it first sends that domain name to a DNS server, and the server responds with the IP address of what you need to connect to. And yeah, that's about it. Okay, a bunch of things about DNS servers is that they store their data in trees, and yep, that's all. Okay, so what's the difference between the internet or the World Wide Web? Um, does anyone know? Guys? Is the pace okay? I don't know if you guys already know all this and you want me to hurry up. Okay, so the World Wide Web just runs on top of the internet, and it's what's responsible for requesting all the content that you see and presenting to you on your screen. So basically, it has two components. It has to request to a bunch of web servers, and it has to go find the content that you're looking for. And then it has to render it and present it to you on your screen. So web servers consist of systems that store and host all these applications. And web browsers are what help you retrieve, like they send requests to these servers and then they interpret the responses that you get. Okay, so at its core, what it runs on are these thick or web pages. Web pages are basic. They have special kinds of text called hypertext, which is basically text with hyperlinks. You guys are already familiar with what hyperlinks are. You basically, if you click on a hyperlink, it directs you to a different web page. And at its core, that's what the web is built on. Okay, anyway, to distinguish regular text documents from and links, there's language called HTML, which again most of you are probably familiar with, but it has like a anchor tag or this A tag to basically specify what exactly is a link and what is not. In HTML, you have a bunch of, you can format things. You have a bunch of other tags. There's headers, there's lists and all that. So basically, you would type to make your own web page. You would type a bunch of HTML code, and if you wanted to add links to it and you wanted to create a hyperlink on that web page, then you'd use the anchor tag. So that's kind of how you make all web pages. But how exactly do you find them when you enter it into a search engine or something? Okay, so how the web works. Every page has a unique address. The first thing your browser does is a DNS lookup. So again, you only have the name, the human readable English name of the website. When you send it to the DNS server, it replies with the IP address that you need to connect to. And then you connect to that IP address with the TCP session. And then you send it a request in using the HTTP protocol, which is, yep, okay. Again, the subtle difference between HTTP and HTTPS is that HTTP just sends very human readable requests over the internet. So it's very susceptible to people just intercepting that request. And because it's not encrypted, anyone can read it, anyone can change and modify it. But HTTPS is encrypted, so it's much more secure. Anyway, the server will respond with the requested page, which will have HTML, CSS, and JavaScript. These could either be like static pages, as in they're just constant pages that are just stored on the web server, and that's exactly what it gives back to you. Or they could be dynamic, as in they're user specific. So the user might request a bunch of things, like suppose you're on Amazon and you're looking for some things, and you might get recommendations based on other things you've bought before. So that's a web page that's customized for you, that's user specific. So someone had to, so there's scripts running on the server that basically make that web page look the way it is. It gives you a bunch of things that are specific to you, the user. So yeah, that's the difference between static and dynamic web pages. Next, you have a bunch of vulnerabilities in HTTP. Again, since the request can be intercepted, they can actually even be modified. So a bunch of things like the headers of HTTP requests, and we look into exactly how this request looks like on birth. But basically, you'll see that a bunch of these things that servers might take for granted. They might think, okay, so I can just use this thing that's specified in the request to generate all this content. But they kind of sometimes they forget that people can modify those requests. So a malicious attacker can change the header, or they can change a bunch of things in the request to make it do something it wasn't intended to do. That's why it's important for servers to basically check if really check for vulnerabilities, and we'll see how to do all of that. Next up, we have search engines. Okay, so far we've covered exactly how DNS lookups happen and how you get a web page that you requested. But if you don't already know what you want and you're just searching for you're searching a random keyword. Okay, so you have search engines that basically give you a bunch of web pages ordered in some way that have things related to what you're looking for. How do those work? They basically use these things called web crawlers, which are automated bots. They start off with a bunch of specified URLs, and then they go to all the web pages mentioned by those URLs, and they parse through the page and they look at other hyperlinks found in the page. And that way they move on to these other hyperlinks and the other URLs and more URLs. Basically, they just crawl the entire web. And then everything that they come across while they're doing this crawling, they enter into like an index. So basically, they read all the text on the web page and they'll take in all the text as keywords. I mean, not keywords. They basically just keep a list of which web pages have what text and in what frequency. Or okay, and then on top of, after crawling and indexing, basically what your search engine does is it arranges all of these web pages in some order. Before Google became popular, they used to just arrange them in order of how frequently your search word appeared in the website. So if you looked up, say, dogs or something like that, that it would basically show you websites that mention the word dog a lot. Except a bunch of people try to work around the system, and basically they would create these web pages that just spam the word over and over again. So this search algorithm would sort of just open those spam pages first, which just had the word dog over and over again. Anyway, now modern day search engines, what they do is they work on this thing called backlinking. So they basically measure how reliable a source is by looking at how many other web pages link to it. So they look at all the links that lead to that web page, how many people have cited that web page. And based on that, they give you the results. Okay, so a small note on something called robots.txt. We just discussed what crawlers are and how they basically parse through all the pages on some website. Robots.txt is basically present in the home directory of the website, and it tells the crawler how to interact with all the web pages. And so it can allow a few directories, it can disallow a few directories. Disallow basically just means that crawlers won't they won't crawl into it. So basically they won't add things to the, you can't Google the website which is disallowed, and it won't show up because the crawler never indexed it. Okay, so onto HTTP headers. These will probably make more sense once you've actually looked at a request. But basically these two are things you should probably remember for when you're trying to exploit some vulnerabilities. Basically, okay, so all of you already probably know what a proxy is. It basically just sits between you and the server, and it forwards your request to the server. That's a forward proxy. Or another thing is there'd be a proxy that basically receives all the requests sent to a specific server, and it basically tries to divide the load onto multiple servers, and it balances the load a little bit and forwards it to the server. Basically, that's all it does. But basically, since these proxies are forwarding a request, the host header might change based on what request the proxy itself is issuing. So if the host, okay, so in this example, some client has requested to go to the blog.example.com, and this is a reverse proxy that basically has to forward this to some server. Now, when it forwards it to this server, in the request, it's gonna say host and backend.example.com because that's where you want to go. And then, but it appears that the client has requested blog.example.com. So now the backend knows what the client requested, and it can process it based as if the request was directly from blog.example.com. So okay, now that we know that HTTP is not safe and we can modify these headers, we can also look at how we can use X original host and X forwarded host for our own advantage and to exploit things. Either way, so when you log in to some website, it has three aspects of security it has to take care of. One is the person that's logging in is really who they say they are. So most websites will do this using some username password mechanism. So only the person that created the account will know both their username and password. So that's what authentication is. You're trying to prove that the user is who they say they are, and they're the same person that created the account, and they're the person that gets to view their own data and all that. Session management basically means that the same user is doing other things on their account. So this is another thing that people have to implement because other people shouldn't just be able to, a different user shouldn't be able to use the active session of some other user. So that's what session management is. And access control is that every user is authorized to do some things. Like some person might be authorized to buy a few things, but they're not authorized to delete accounts of some other user. Access control is what determines what some user can do while on that site. Anyway, now that this was a very basic overview of everything, uh, you will probably gain a lot more clarity once we start actually looking at some examples on Burp. So okay, I'll share these links with you on the chat if you guys can open it. The very first thing, so we're moving on to authentication vulnerabilities. What that means is, in some way, I'm not actually the person that's whose account I'm about to access. So how do I? So there's a vulnerable website, and you're logging into someone else's account, and that's what authentication vulnerability is. So in this first example, it says lab user enumeration via response timing. Okay, so first things first, what's username enumeration? Basically, servers respond differently to a username that's valid, and they respond differently to a username that's not valid. Say I so in it so usually you would see the prompt that asks you for both the username and password. If you enter the wrong password, if you enter a bunch of um, very obviously wrong credentials, it'll just immediately return invalid username or password, right? But sometimes you happen to chance into a username that's actually valid, in which case the server has to do like the additional thing of checking if the password matches with that of that original account. So we'll go to the list where it stores all the passwords and all the usernames, and then it has to parse through everything, and it has to find and check if that password matches. So there is like a slight difference in time, which allows us to basically figure out that okay, the username I just entered is an actual username. So this wasn't a vulnerability people that designed ever intended. Like they had no idea that people also had access to how quickly the server responds to something. So either way, we're gonna try to use the fact that a valid username takes longer for a response than an invalid one. Okay, so I've sent you guys the link. Please open this using. Uh, okay, so first you'll open Burp, and then you'll open browser, and then you'll open that link. I'm not sure what that is. If you know how to use it, sure. Okay. Okay, so this is the lab that I'm hoping all of you guys open. So it says that this is vulnerable to username enumeration and password brute force attacks. It has an account with a predictable username and password, which can be found in the following word list. So just open the bunch of usernames and passwords. Okay. To solve the lab, enumerate a valid username. So the first thing we have to do is identify which of these usernames. And there's about 100 here. We have to figure out which of these usernames is actually a valid username. And then for that specific account, we have to figure out which password matches. Okay, so click on Access the Lab. Okay, so when you go to burp proxy, you can kind of see, and under target, you can kind of see exactly how many domains it's visiting or which sites it's visiting. So you go to the one which has the lab, and then you see all the requests that have been issued to and from this URL. Okay, so you go to my account, and I'm just enter some random credentials that you know are not valid, and then again some random password, and you hit login. You'll see that it gives you an error that says invalid username or password. And then you head over to the proxy again, and you look at which so the response so the request that you have to look at is in this case going to be post and slash login, because that's the one that's giving you this response which says invalid username or password. So typically you'll see two methods, two HTTP methods, get and post. Get basically just well, post basically will incite some response out of the server, and it's going to it's going to change some data in the server, or it's going to submit a bunch of data. So that's how post methods work. So anyway, once you get this request, you can hit send to intruder. And you go to intruder. Basically, remember what our goal was here. Okay, first off, if I just okay, first send this to repeater. So if I just changed how long this thing is, and if I hit send, you'll see here that it took 166 milliseconds. And as I increase how big this is, it should, again, it's approximately the same time. So it doesn't even check if the password is matching, because it already knows that this username is not valid. But if I gave it a valid username, and okay, we don't know which username is, we don't know much about any valid usernames, but usually there's something for admin, or because I'm familiar with this. Okay, we don't know much about which might be valid usernames, but one thing you'll notice is that right now it's around the time it takes to respond, which you can see on the bottom right, is around 160 milliseconds. But if I give it some valid username, what you'll notice is that this will take much longer to process this whole string and then determine that, okay, this is not the actual password. So basically, if I enter a valid username here, my response time is going to be significantly higher than 160 milliseconds. Anyway, since we've already sent this request to intruder, again, remember our goal here is to first find a valid username. So what I'm doing here is it's already been set to sniper attack. I'm assuming all of you have opened this already and you forwarded the request to intruder. So anyway, the attack set is the sniper attack, which you basically just brute force one single parameter. So when I add this symbol around the thing, I highlight it and I add that, and I can set the password to some really long string. Say, doesn't matter really. Just a really, really long string, because we want to see if this thing is actually checking if the password matches for a valid username or not. So anyway, now we go to the list of usernames that we've been given. And we go to we paste this in payload configuration. So what this does is basically it tries out every single one of these usernames and it checks, and it'll basically give you like a report in the end. So okay, we'll start that attack. This will take a little while to run, so okay, again you can see here that the response takes around 160 for 160 or 157 or so on for all of the usernames. But there'll be one username that sticks out a little bit. And yep. Are all of you with me so far?
Yes.
Okay. Okay, so you can sort all of these requests based on different parameters here. So you can sort based on ascending or descending order of the status code by clicking on the little arrow next to it. Or you can sort all the payload based on some order, alphabetical or whatever. Here, since what we're trying to do is we're trying to figure out which of these usernames is valid by sorting the response time. So if I sort it in descending order, I see that this person has this person's response is around 200 milliseconds, which is still not a lot. It would take a lot more if it was a valid username. And you can see all of these lie close to each other. Okay, so right now it just ran a request for some user named app, and we see that their response time is 400, which is double of the next biggest one. So it's most likely that app is the user that we're looking for. And so we can stop the attack, and we know that, okay, so this is a valid username. Wait. So you can stop the attack, you can discard it, because we already know that, okay, this person's the valid. Okay, so in the username parameter, you just fill in app. And now we're trying to guess app's password. So again, this is again going to be a sniper attack, because you just have the one payload and it's the password, and we're trying to figure out the password. So you can copy paste the list of passwords. Clear the old one and paste it, and once again it's the same. This time we're hoping to receive either, okay, so all of the lengths are different, so I can't really sort or figure out which response is valid based on that. But basically we have these things called status codes, which browsers usually send back like a 200 to. Basically, the status code is different for. It's recommended that it remain the same for multiple actions, but sometimes for a valid username, you might get a different status code because. So that's what we're trying to do here. We're sorting based on the status code to see which of these passwords gave us something different. So that would indicate that, okay, that's the right password. While that runs, anyway, so this is what a request looks like. So you see all of these headers that are in the request. We have a bunch of cookies. We have a session cookie. Okay. So all of these are different headers, and as I was saying, in the slides there was this thing called X forwarded host or X original host. Those are basically headers that proxies add to identify which domain the client initially wanted to visit, or so they preserve the original request, or um, they direct it to a different host. So they'll signal that, okay, this is where the server needs to go to process things. So since those are also headers, if I were to manipulate this request, I would add something here along with all the headers. So I would add either forwarded host or X original host. And we'll look at examples where that's required too. As of now, we'll just wait for the tag to finish. Wait 1 second. Did I give you guys the right link? I can't remember if this is the one I gave you. Okay, yep, that's the one I gave you. Wait a second. I'm gonna stop the attack. And address some of your doubts. 1 second. What happened? You guys able to access the lab? There's no app in my list. Oh, it's not gonna be the same for everyone. That was just an instance of the lab that was running for me. It'll be different for all of you. You're getting rate limited. I don't think that's supposed to happen. How do you start the attack on both? Okay, so I'll just go over the details once more. Since for my instance, the username that worked for me, which had the longest response time, was app. That might be different for you people. So you might get something like Carlos. You might get 123 as your username. Basically, the one I chose was the one which gave me. No, not for. I don't think we were supposed to use X forwarded for. One second, I'll project and show you something again. Okay, so when you use X forwarded for is basically if there's like an IP block. We'll see what that means in a bit. So basically, I know that this is definitely not the password for. We found out the actual name is app. So I'm sending this request, and I see that it still says invalid username. I can send it a bunch of times, and we see that we're not really getting locked out. So we can say that this lab doesn't lock out based on how many times you attempt. So it's great for beginners because there is no brute force mechanism against it. So no matter how many times I send this very obviously wrong password, it doesn't lock me out. So you could use X forwarded for only when there's an IP block, and we'll come to a few questions that have that. So either way, let me just start that attack again. I shouldn't have stopped in between. While it's running, I'll address all of you guys' concerns. Okay, I'll send link again. One second. Mm. Oh, okay, my bad. Yep. I was. Okay, one second. Oh yeah, my bad. There's slightly different responses. So this one was the. Did I send you guys the second one or the first one in the initially? Okay, okay, I was. My bad. I'll resend that, and I'll also work on the same thing. Really sorry, guys. Okay, so now I'll access this lab. Okay, so there's a hint given which says the lab also implements a form of IP-based brute force protection. Okay, so here's where you would use X forwarded for, and I'll show you how to do that. This can be easily bypassed by manipulating HTTP request headers. So once I've gone to the lab, I go to my account And we've been given credentials, Weiner and Peter. I'm gonna deliberately enter a wrong password. Okay, and now as I go to burp, I see that, okay, so this lab is A7 something. I can go to my scope and open that specific lab. And here I have the post request, which I can send to the repeater. All of you following around till now? Is it fine? Okay, so this is a password that I know is not right. So the password given to us was Peter, but I am logging in with some password that says test. So when I send this, it says invalid username or password. Send this another time again. And now it tells me you've made too many incorrect login attempts. Please try again in 30 minutes. So basically what this tells me is that it blocks either the account or the IP address if I send a request from the same one many times. This is to prevent attackers from using brute force mechanisms against this. So here I'm entering a header called x forwarded for, which is basically, so if I've changed this, x forwarded for is basically the IP addresses which the request has traveled through. So it basically tells the server that, okay, this original request came from an IP address of 0. It's not a real IP address, but we'll see if this thing basically resets. So yeah, we see that it changed the message from you have to wait 30 minutes to this is an invalid username or password again. So again, I have 3 trials. If I send it a 4th time, it's going to log me out again. So I can change the X forwarded for to a different IP address and I can continue my attack. So this is the process we're trying to do with Intruder. We're trying to change the IP address every single time. So so we send this request to Intruder. And okay, so we have to set 2 parameters, which are via response timing. Okay, we're just trying to find one valid user and we're trying to brute force their password. Okay, so basically the request we have here is going to reset after every 3 attempts of logging in through the same password. So I'll write the x forwarded for header and I'll enter a 0 and I'll add it as a parameter. Also, we're changing this from sniper to pitchfork attack. So what happens in pitchfork is that you have 2 payloads. So in this case, my username and this IP address are my payloads. And I'll give it like an impossible password. That's definitely not a password for anyone. So that, okay, and since the goal of this lab was to figure out which of the responses are true based on, okay, so we give it a really large password so that we can see there's a significant difference for valid and invalid usernames. So, okay, in the position of my first payload, I want you change it to numbers from simple list. And you start from, say, 3 and you go to 103. And you step by 1. And for my second payload, which is my username payload, I go to this page which has all the usernames and I input all the usernames. and I start the attack. So payload 1 is your IP address, which it's changing every single time, and payload 2 is your username. So we want to see which of these payloads takes a really large amount of time. So we'll sort it in descending order based on response received. Are all of you able to get it now? I'm really sorry I accessed the wrong lab last time. Okay, so for me, I came across a payload that took about 500 milliseconds to return a response. So I know for a fact that this is a valid username. So for me, it's AS400. It might be different for you guys. So I'm stopping the attack. And now in place of my username, I'm going to enter AS400. And in place of, and now I change my payload position. So now that I have the username, the valid username already, and I've enumerated a username, I'm trying to guess AS400's password. And okay, so we have a bunch of passwords here. And in the position of my second payload, so the first payload is again sequential numbers from 3 to 103. It's fine if it's the same numbers, it won't get blocked because we saw that you'd have to send a wrong request from the same IP 3 times, and we've only done it once. So it's okay if we leave that to be the same. For my second payload, it's again a simple list. You hit clear and you paste all the passwords there are. There's about 100 of them, and now you start attack. So one of these will respond in a different way. Either the length is going to be different because it's given you a different response, or the status code is going to be different. So this is us trying to guess AS400's password. Are all of you guys able to do it now? Guys? Okay. So I'm going to sort this based on status code. Okay, and I already see that the password is soccer because it's returned a status code 302 and the rest are 200. So I can stop this. So I can go to the lab, and for me, the username I found was AS400 and his password was soccer. Oh, 1 second. I can just send it in through repeater. The username was 400 and the password is soccer. And I'm gonna set my IP to 20. Okay, so now that I've sent that, I should hit reload. And this should solve my lab because am I spelling soccer wrong? Either way, this basically responded with a 302, so that basically means we solved the lab. Okay, so on to the next. Okay, so on to the next lab. This was the one I sent you guys originally. It's got a very similar logic. You're basically, it doesn't say different timing. And the logic written here is sometimes the error message that it shoots off is different for valid and invalid usernames. So it's usually recommended for this exact reason that people can brute force based on how differently a website responds to a valid and invalid username, and that way they can enumerate a bunch of users and say which ones are valid. For that very reason, it's usually recommended to give the same response for both valid and invalid usernames. So usually you'll see a response like uh, you'll basically just see invalid username or password when you enter the wrong credentials. But sometimes there's a subtle difference in the message that shows up. That could be like a trailing space, or there could be like a space between some of the words, and that's how you'll be able to differentiate between valid and invalid usernames. So I'm not going to do this lab because it's very similar to the last one. The only thing that's different is that basically when you go to intruder, there's also um, an option to second. Okay, so okay, maybe I should just do it and show you guys how to use. Oh, that's only for sniper, I think. Or no, actually, we'll just do the next one. I'll send you guys this link. Okay, so basically, this is something called reset poisoning, which is when the server uses the request itself to somehow. Okay, so you get these links in your email, which basically you get when you say forgot password, and it sends you a link in your email. And it has like a token attached to it, which is it's very random. So it's not easy for a hacker to guess the token. It's very likely that only the server will destroy it after the persons have already used it to reset their password. And it's usually very hard to brute force or guess because it's a long token as well. But basically, there'll be a subtle flaw um, which allows the attacker to basically, instead of they can manipulate the URL itself. So the original URL would have to be HTTPS and then the name of the server and then password reset token equals. But now, if I can suddenly manipulate some of the headers, it's possible that I can direct the link to an exploit server, and when the user clicks on it, they basically will I'll get a notification of what that token is on the exploit server. So once you have that token, it's easy to just um, you can just change their password because you have that token now. Okay, so that's the lab we're trying to do. Okay, so this says this lab is vulnerable to password reset poisoning. The user Carlos will carelessly click on any links and emails that he receives. To solve the lab, log into Carlos's account. You can log into your own account using the following credentials: Weiner and Peter. Any email sent to this account can be read via the email client on the exploit server. So I access the lab. All of you, by the way, stop doing the previous ones. You you can go back and try solving them on your own. There's a lot of really good YouTube videos on it. If you just type in the name of the lab, there's also the community. There's also a solution given below the lab itself. So you'll get plenty of time to understand what's happening. But right now, just focus on the lab being done. It just takes a little while to get used to the interface of Burp, but it's actually very understandable and very fun. Okay, so anyway, the credentials I've been given are Weiner and Peter. So I'll log out, and when I type Weiner and I click, wait, was there forgot password? Is there a reset password inside? Nope. Okay, so I basically have to click on forgot password, and Weiner is my username. So basically, this is going to give me a response on the email. So I go to the email client, and so you can see that it's generated some link on this form, which is basically the attack site, the lab's domain name, followed by some temporary forgot password token. So anyway, we know how that works. So now uh, we're trying to find Carlos's token, this temporary forgot password token. So, okay, so now I go on to Burp, and okay, so I have a I have get forgot password, which basically just, and then post forgot password, which sends a link to, okay, so I'm gonna send this to repeater. One second. Okay, so if I just basically just send, it generates a high entropy token, and it sends an email to that username Weiner. So in this case, so I've also one second. Okay, so my goal here is to I don't want the link that's generated for Carlos to have the attack. I wanted to have the exploits. I wanted to have the exploits URL. So So once I, okay, one second. This is the URL that I wanted to go to. I don't want it to go to the um, labs URL. So basically, here is where I'd use the X forwarded for host header, because what that does is it basically tells the server that, hey, this response, this is what you need to use for your response. And I've given it the URL that it has to replace at this. And I change it to, one second, I go back to this and I also forward the get forgot password to repeater. Never mind, I don't need to. Okay, so I just do this and I enter the username Carlos because I wanted to generate a link for him. So what this will do is it's going to use this modified HTTP header, and instead of inserting the labs address, it's going to insert this, and it's going to generate it for the username Carlos. Okay, so since this is just a host, I think we're just supposed to, I'm not sure about, either way, we'll send this and we'll see what happens. Okay, so it's sent some email to Carlos, and we can see that, oh, my bad. So Carlos must have back to exploit server. If he clicked on the link, and we've been told that he clicks on every link there is. No, it seems I made a mistake. He did not click on the link. So I think it's supposed to be /exploit only. Nope, still not. Am I missing something here? I've given it the exploit servers link and I've changed the username to Carlos. Oh, one second. Okay, so I see a couple of responses which start with 10-0, and some of these are from the victim, I think. So we see this forgot password token. Oh, I got 3, my bad. Don't know which it is. Okay, I think it's the first one. I can't be sure. So Carlos has clicked on all 3 emails that we've sent him. But since the latest one was this, I think this is the token I'm supposed to use. So anyway, we go to this, and again we go back to all the, so okay, so when I go to my email client and I click on this link, it takes me to confirm. Okay, so I can enter some new password. I'm going to make it test and confirm new password, and I submit it. So this, by the way, just changed Winer's account to test. So if I go to that forgot password, so this request has the token and the new password test. So this is what I now need to send to repeater. So once you've sent this to repeater, and we already have Carlos's token, this is Carlos's token that I pasted. So I changed it both in the parameters down here and the query parameter on top. So this is the one with the lab's domain name in the URL. So it doesn't have an X forwarded for and all that. So we change it to Carlos's token, and we're changing the new password to test, and we're sending it. So okay, we've successfully changed Carlos's password to test. So hopefully this works, or we know that I chose the wrong token. Yep. So we've solved the lab, and that's how you change his password using the exploit server in between. Okay, so on to the next lab. We have something called password brute force via password change. Okay, I don't remember what this lab had. Let me just, I'll send you guys the link. So it says that this lab's password change functionality makes it vulnerable to brute force attacks. To solve the lab, use the list of candidate passwords to brute force Carlos's account. Okay, and access his my account page. So okay, I've been given my own credentials, and this is the victim I have to do it for. It says that it's vulnerable to brute force attacks, but okay, I access the lab. Go to my account. The credentials I've been given are Weiner and Peter. Okay, so here we've been given something that helps us change our password, and we can just observe how this page reacts to things. So the current password I provided was Peter. Now if the new password is test, and okay, so if I enter the wrong current password, which is what we'll do when we're brute forcing for Carlos, we'll enter a bunch of wrong passwords, right? So if we enter a bunch of wrong passwords, I'm gonna enter some random string, and my new password is test. And I hit change password. I get logged. Okay, so I don't know if that was Vina Peter. Okay. Okay, so I basically get logged out if I enter the wrong password. Okay, so I find this lab in my targets. I go to my account. I forward all of these to repeater. My account change password to repeater. What I notice is that if I send it this, it basically just logs me out. And if I do enter my correct password and I enter two different strings, you know what this does. I have to wait a minute and then check again. So basically, if the two entries for the new password match, the account just gets locked. But if you enter two different passwords, we have to see what happens. So I'm gonna log in. I think it's been a minute, so I'll log in back into the account. And this time I'll enter the correct password. Wait, no. I'll enter again a random string. But what I'll do is I'll enter two different strings for these two fields that ask you for the new password. And when I hit change password, it says current password is incorrect. So this is really bad, because now if we change, we go into Carlos's account, we can basically just keep two different fields for new password and for these two fields, and basically it's going to tell us if the current password is wrong or not. And if the current password is not wrong, let's just see what happens. So I've entered Peter in the current password. It gives you this, which tells us the new passwords do not match. Okay, so basically our goal is to find this when we're brute forcing for Carlos's Carlos's password. We want this error message that the new passwords do not match, because it means that the current password was right, but these two aren't matching, so I can't change my password. But if the current password is not right, then it just gives me the error message, current password is incorrect. So, okay, I have this here. I'm changing the username to Carlos. Okay, also I'm sending this to intruder. I've changed the username to password. Change the username to Carlos, and I'm making this my payload, and you can see here that the new password 1 and new password 2 are not changing. Are different, so I don't get locked out. So now we just take this list of passwords and we launch the sniper attack. Also, we go to settings. I think it was payload processing. One second. Since we're trying to look for this message, new passwords don't match, there's an option that basically lets you sort error messages based on, but you have to find a tool called grep. Okay, so in the settings panel, you have something called grep. I want to add something here. Wait. Okay, so in my repeater, okay, so when I rendered this, I got logged out. Okay. This is from the previous one. Okay, I'm gonna send this to repeater. And So in my intruder, I'm trying to one second, guys. Search for password. Okay, so usually okay, so here so since his password is not Peter, you're gonna get current password is incorrect. So this is what you're trying to look for. This is what you're trying to grep for in your intruder. So I'll forward this thing to intruder again. And this is my payload. And I'm gonna copy the list of passwords into this. And I go to my settings panel on the side here. And I'm trying to extract something from the, okay, so here you can see that I found my response in the grep thing. So what this is supposed to give me is current passwords do not, yeah, current password is incorrect. So I'm basically looking for this. Okay, so now that I've added this condition, what it does is it's going to add an extra column in my result tab. Okay, so basically it's for every wrong password, it's going to give me the current password is incorrect. But when I get the right password, it's going to tell me that the new passwords don't match. So in descending order, because n is after c, if you sort it, you should get a message on the top here that says new passwords don't match. And that would mean that you got your right password for Carlos. Is everything clear so far, guys?
Yes.
Okay. You guys get how to use grep? Okay, I'm gonna assume that's a yes. Okay, so we found something that says new password does not match. And it's for the password George. Okay, so we basically found Carlos's account's password. We can stop the attack. Okay, wait. Go to Peter, and now his password is George. And now I set the same password for both of these. And now I see that, okay, his password's been changed. I go back to my account and I log out. And now Carlos's password is test because we changed it. And we solved the lab. Okay, now I think that's enough of authentication labs. We'll try some of the access control labs. Okay, so we finished. Yeah, and we'll come back to this if we have to. So access control is basically what gives users permissions to do things on a site. So if I'm not an admin user, I shouldn't get to delete other people's accounts, or I shouldn't get to promote them to admins. So if I'm a regular user and I'm able to gain admin privileges, that's called a vertical escalation of privileges, because I'm able to do something that my level of users should not be able to do. And horizontal escalation basically means that I'm able to access the accounts of other users at the same level. Okay, so here I'll give you guys this link. It says lab URL, URL based access control can be circumvented. And I'll tell you what that means in a bit. Yeah. The website has an unauthenticated admin panel at /admin, but a front-end system has been configured to block external access to that path. So basically, I cannot access the /admin path. However, the backend application is built on a framework that supports the X-original header, X-original URL header. To solve the lab, access the admin panel and delete the user Carlos. Okay, so when I go to this lab and okay, 1 second. Let me just clear all of this out because it's confusing. Okay, so I see that this is something called AF. Okay, so first things first, I am trying to capture the request that I get when I type in the URL of this and then /admin. So I'm going to go to proxy and I'm going to turn on intercept. And then I'll go here and I'll try to access /admin. And basically intercept is not going to let this. So I'll forward this, and then this is the one that I'm going to forward this to repeater. It's get and then /admin. I'm forwarding this thing to repeater. So basically now if I forward all of these, I'll basically see this prompt which says access denied because I'm not logged in as an admin user. And after that I'll turn intercept off. Okay, so since I've sent the message to repeater, it's already been specified that this thing it does not grant you access if you're not logged in as a so I basically can't access the admin panel unless I'm already logged in as an admin. So I can't access that unless I change. Okay, so basically what I'm going to do is I'm going to go to X original URL. As we remember, this is not going to let me access it since I'm not already an admin. But what this is telling the backend server is that, okay, this person, whoever is issuing this request, is coming from the original URL slash admin, which must mean they're already logged in as an admin. So, and I have to change this. This basically means I'm trying to get to the .NET domain. So I'm just trying to get to the lab itself because I can't access slash admin. But we'll see if this is vulnerable to this. And when I send it this and render, basically I can see that now I've been logged in as an admin. Okay, so what's the goal of this lab? Okay, we have to delete the user Carlos. Okay, so I can go to my repeater and I can request in browser in original section. Okay, so basically this is how I've already logged in as an admin, and now my goal was to delete Carlos. Oh, my bad. So you can't do that directly because still it's checking if you're already logged in as. Okay, so I think for this you change the X original URL to admin/delete because that's what that's what the admin, if you were logged in as a admin, that's what you would be able to access. And here I've added a query parameter username Carlos because I don't want to delete Wynerd's account. I want to delete Carlos's account. And I've changed the original URL from /admin to /admin/delete. And we'll see if that works. And yeah, as I can see in the background, the lab's been solved. So basically the reason it didn't work when I tried to open the same link in the original session was because I was still not logged in as an actual admin. I can only change the URL which the backend processes. I can't open it directly because I'm not authenticated to. Okay. Was that clear for everyone? Yes, you can unmute and speak. Okay, I think that was supposed to be a thumbs up. Okay, so the next one we're doing is indirect. Is someone raising a hand? You can unmute and speak. Guys, what else did you change apart from, yeah. So basically, like I've explained, what X original URL does is that it doesn't actually change. I'll still be sending the request from my account, which is not an admin's account. So if I try to open it in the browser, it won't open because I am not logged in as the admin. But this basically tells the backend that, hey, this request or whoever sent it, it was sent from the original host name. So if I change the X original host to /admin, it's going to tell the person that, okay, this request came from /admin. So what I changed is I changed the X original URL to /admin/delete because again, now this is going to tell the backend that, okay, this request came from this URL /admin/delete, which means the admin is trying to delete something. So the backend is going to replace this thing. It'll basically replace it here. This is the same as issuing this whole URL. Because there's And I've also added in this is called a query parameter. Basically, whenever you delete or you try to access some specific item number, you might have seen something with a question mark following ID number equals 1234, or you might have seen something in the URL, right? Those are called query parameters. One second, I'll just show you what they are. Okay, so this is what it looks like in a URL. So it has a question mark and it has parameter equals something. So I changed both the original pathway to admin/delete, and then I gave it an additional parameter, username equals Carlos, because I don't want it to delete Viner's account. I only wanted to delete Carlos's account. Is that clear now? Oh, okay. But I've solved the lab, so I don't think I can redo it with the same account. But okay, we'll go through it again. Basically, once you've captured the request for /admin, you'll see that you're not allowed to. So you go and you find the request for /admin, which for some reason I wasn't able to capture here, which is why um, I had turned on intercept before to capture that request. So I'm gonna turn on intercept and then did you enter the modified header in the right place? Because sometimes that if you don't enter it in the right place, you kind of oh yeah, you can't go to I know because I've solved similar labs and yeah, usually it's just username is the parameter. No, I didn't go to the admin panel. I tried to open it, but it wouldn't open because I wasn't opened. Oh, do you mean the response in repeater? I wasn't able to open it in the browser. But yes, it does show you the response in repeater, like next to the request. Um, did you mean this? Um, like this? Oh, no, that doesn't mean that you've opened the admin panel with your. Oh, it doesn't? Hmm. I I don't know why that would happen. Did you enter it in the right place? Like you have to enter it along with all the other headers. Okay, and also you have to, if you didn't remove it before that, there was a get/admin here. You have to remove the admin because you're not authorized to add, you have to remove the admin from there. Did you do that too? Okay, okay, cool. Okay, so I'll send you guys the link to the next challenge. Did I send it already? But okay, I'm gonna turn off intercept. And I'm gonna go on to the next challenge. So this is something called insecure direct object references. back to the slides for a second. Why are we requesting it from /admin? So because a normal user like Viner cannot delete Carlos's account. Like you have to be an admin. Isn't /index page? Yeah, slash is like the home directory, and /admin is only available for admin. Okay, so maybe I should do a simpler. Okay, can all of you go to view all access control labs and go to unprotected admin functionality. This lab has an unprotected admin panel. Solve the lab by deleting the user Carlos. You won't really even need Burp for this, I think. Did all of you go to that one? I think it'll make it clearer for you. So here I go to robots.txt. One second, I don't know if it exists. Yep. So robots.txt, as we discussed earlier, this is a text file that lies in the home directory that tells the crawler how to interact with all the web pages. So it's saying disallow administrator panel, which I'm guessing is pretty much the admin panel. It's telling it to not crawl this panel and not let anyone just directly search this. But once I click on /administrator panel, I see that this thing opens and I can delete Carlos's account just like that. So it basically just means that that specific web page is only available for admins. And that's why we go to /admin. So okay, on to what in insecure. Is that clear? Okay. Okay, so what is insecure direct object reference? It basically happens when an application doesn't. One second. When an application uses user-supplied input to access objects directly, consider a website that uses the following URL to. So basically, this is what I meant by query parameter. You see that it's on this page, insecurewebsite.com/user account, and it's trying to find this thing from a database. It's trying to find the customer number, and this is the value. So there is the name of the query parameter and the value. And we all know that URLs are changeable by the user. So this isn't a safe way of referencing that object because anyone can refer to any object like this. Here the number is used directly as a record in index and queries that are performed on the backend database. If no controls are in place, an attacker can simply modify the customer number value and bypass access controls to view the records of other customers that they're not supposed to. So they can view accounts of other customers, basically. You can also have this for, instead of retrieving something, you can also find static files in the same way. So you can just change this number. Instead of 1124, you can just have a different number and you'll be able to access that if it's not correctly it's not correctly making sure that the URL is not being used to open the object. Okay, so anyway, I'll send this link to you guys. And I think this is gonna be the, oh, I already sent it. Either way. This is gonna be the last lab for this session. Okay, so since we have to find the password for the user Carlos, and this stores chat logs directly on the server's file system and retrieves them using static URLs. So we already know it has something to do with the chat. So we could just go there, and I am connected. I am now chatting with Hal, someone. I can just say this and send. Uh, when I click on view transcript, what happens? It basically downloaded a file for me. So uh, I'm gonna go try to look at that in, okay, it's A7, 8, yep. So it says there's something here that's called download transcript and get slash 2.txt. So how about I send this to repeater? So when I tell it to get, okay, so when I tell it to get 2.txt, this is exactly it. The chat that I had with this guy, which is, I looked that up when my nail polish is dried. I should get exactly that. So I sent a hi, and he sent, does your mom still know you're up? Okay, so if I change the numbers, since this is a question that's based on IDOR, I know that this is retrieving other chat logs in directly through the URL. So if I try to access 3.txt, it says no transcript, or just try on different numbers. So 1.txt. So this says, hi, forgotten my password. Okay, so this is someone's password, and I think it's Carlos's. Okay, so you go to my account, and we've solved the lab. Okay, do you guys want to do one more? The access control labs are very short. Okay. Oh, was that a yes for this? Okay. Um, with no access control on one step. I've sent the link. This lab has an admin panel with a flawed multi-step process for changing the user's role. You can familiarize yourself with the admin panel by logging in using the credentials. Okay, so log in using the credentials Weiner Peter and exploit the flawed access controls to promote yourself to become an administrator. Okay, one slight thing to note here, when they say login using the credentials, there's something called a session cookie, which basically, remember that thing we learned about session management that basically ensures that the same user that logged in is the one that's still using the session. So basically, the server does this by generating, sometimes it does this by generating a cookie, which it identifies the user with. So one way I can log in using the credentials Weiner Peter is obviously to just log in with those credentials. And the other way to do it is by, so this admin.admin is going to also generate a session cookie. But if I wanted to pretend that I was Weiner from this request, I would just have to paste the session cookie of Weiner into the admin's session cookie. Either way, I think that'll be more clear when I access the lab. So basically, a multi-step process would be you would have seen it in some forms. So it asks you for confirmation before you submit the form. It asks you to review it and then click on OK. So what happens is sometimes in these in websites like these, they don't always check if the same person is using. So maybe I have to be logged in as admin to get access to the first page, but I don't have to be I don't have to be logged in as the admin to get access to the second page. So here, uh, the goal is to use Viner's account to promote himself into admin, but I don't want to do that from the admin's account. So I'm going to promote Carlos to an admin. And this is what I mean by multi-step process. So it's asking me, are you sure? And now we can see that Carlos is an admin. Anyway, let's go to Burp and look at those requests. Okay, so this is A6. Oh, so it has post. I'm gonna send this to repeater. Also send this to repeater. To be clear on what exactly I'm sending to repeater, I'm sending it this request, and I'm sending it the one where Carlos was promoted to user. Okay, so here, this is basically the admin session cookie. If I replace this with Viner's session cookie, it's almost equivalent to just saying Viner's the one that's doing the upgrading. So anyway, I'm gonna go back to my account and log out. My credentials are Viner Peter. So okay, now that I'm inside Viner's My Account page, hit inspect, right click and hit inspect, and you can go to application and you'll find something for cookies here, and it tells you session cookie is this. This isn't the only way to find the session cookie. You can also find it on Burp, but you'd have to intercept some request sent from Viner's session. So I've copied down his session cookie. I'm pasting it here. So this is equivalent to saying that Viner is the one that's doing the updating. And I'm changing the username. So we're upgrading, and the second, it's a multi-step process. The second one is confirmed equals true, and the third parameter is Viner. If I send this, it says it responds with a 302, which means, yep, we solved the lab. Okay, so that's it for today. I actually had plans to do a few more labs, but I think I underestimated how long Bird would take to run some things. Either way, how's the pace today? Were you guys able to, was it too slow? Were you guys bored? Or was it like a normal pace session and you understood things? In the next session, should I go faster or slower? Any feedback? Feel free to, it's okay if I'm not going to hold it against you if you give me feedback. Okay. Okay, I'll go faster next time. Anyone else? Okay. Not. Yep. Okay, fine. Cool. Okay, guys, you can leave. Unless you want to stay back and. Okay. Okay, I'll do that next time.